Welcome to our channel Data Explorers. Today, let us have a look into one of the emerging technologies, self-driving cars. Our agenda for this video would be to discuss about the following topics. First, what are self-driving cars? What are the different levels of automation? How are these cars tested? And an overview on the Tesla and Waymo cars. Self-driving cars are known as autonomous cars. Now, imagine a car that drives itself and also makes intelligent decisions based on its environment. That would be great, isn't it? Yes. And that will be possible as these cars are equipped with some technologies which will enable them to navigate the roads autonomously, which eliminates the need for a human driver. However, as of now, we don't have any completely automated cars whose level of autonomy is 5. Wait, what's level of autonomy? The level of autonomy describes the extent to which a vehicle can drive itself without any human intervention. We have level 0 to level 5. Level 0 has no automation. Level 1 requires driver's assistance. Level 2 is partially automated. Level 3 is conditionally automated. Level 4 has high automation, whereas level 5 is the level where there is complete automation. Testing self-driving cars is a crucial step in the process of development and deployment of autonomous cars. As we all know, these vehicles are expected to operate more safely and efficiently, and hence, a rigorous and comprehensive testing procedure is essential. Let us discuss a few of the testing processes. Let us consider the simulation testing. This is the first testing procedure. Self-driving car algorithms are first tested in the simulated environments. Here, the developers are allowed to test various scenarios such as weather conditions, traffic patterns, without any physical risk. Second one is a track testing. In track testing, cars are tested on closed tracks designed to mimic the real-world conditions. This allows engineers and developers to evaluate how the vehicle reacts to the real-world challenges. For example, sharp turns, obstacles, and emergency stops, or some unusual scenarios like an unexpected pedestrian crossing the road. All these come under this track testing. The third one is the real-world testing. For example, companies like Waymo, Tesla, and Uber have permits to test their autonomous vehicles on public roads. These tests will help them assess the vehicle's performance in the actual traffic conditions. But then, what is the technology behind all these self-driving cars? Have you ever wondered how modern cars understand their surroundings? All the credit goes to the ADAS perception system, that is, the Advanced Driver Assistance System. These systems use cameras, LiDAR, radar, and ultrasonic sensors to see the world around them. They collect data from the road, traffic, and even pedestrians. This data is processed to create a 3D model of the vehicle's environment. It identifies the lanes, traffic signs, traffic signals, the nearby vehicles, and even the potential hazards. The perception system acts like the car's eyes and ears. It continuously analyzes the information to understand what is happening around it. For instance, if we consider a pedestrian suddenly crossing the road, the system quickly recognizes the risk and takes the respective action, like applying the brakes. By combining perception with path, planning, and control, the ADAS system helps us ensure a safer and more efficient driving experience. All the credit goes to the ADAS perception. Vehicles today are smarter and safer than ever before. Basically, the car takes perceptions or inputs from the environment around it and performs the required actions just like intelligent agents. Automatic cars need to be able to perceive the world around them. As told earlier, The supporting technologies include combination of cameras, LiDAR, radar, audio and ultrasound, GPS and inertial measurement. But what is radar and LiDAR? Why should we use them? So let us see. Radar is used for long-range detection, all-weather performance, speed and velocity measurement, object tracking, and it is known for its cost-effectiveness. Whereas LiDAR is used for high-resolution mapping, object identification, which is common in both, and LiDAR gives us 360-degree coverage, night vision, and also real-time data processing, which is very important in the case of self-driving cars. The completely autonomous vehicles will definitely revolutionize the way we travel, using advanced technologies to navigate roads efficiently and safely. Navigation starts with maps that define paths from the origin to the destination. Some systems use basic maps while others rely on highly detailed maps, including the lane details and traffic. The basic maps include major roads and connections, whereas the detailed maps include lane level precision and traffic signals. Hybrid navigation combines multiple systems using GPS, inertial navigation, and real-time perception to adapt to unexpected changes and obstacles. Here, the hybrid navigation means it is the integration of multiple navigation systems for robust pathfinding. While we talk about deep neural networks, especially the convolutional neural networks, these analyze sensor inputs to detect and classify objects such as pedestrians, vehicles, cyclists, and road signs. Some of the examples are even like identifying the stop signs, detecting people, and other vehicles. These networks segment images into regions based on object categories, enabling the vehicle to distinguish between the road surface, lane marking, and sidewalks. The key function of this segmentation is that it classifies and separates different areas in the driving scene. In the complex scenarios, the system understands the traffic and also it integrates data from multiple sources to learn from the environment surrounding it. This vision-only system demonstrates an innovative approach by utilizing 8 cameras to build a comprehensive bird's-eye view, relying solely on visual data. The vision-only system contains cameras which create a complete environmental view without additional sensors. With these cutting-edge technologies, autonomous vehicles are paving the way for a safer and smarter future in transportation.
Subscribe to Data Explorers.